Hello everyone, thank you so much for registering on this particular course, which is Mastering Azure Data Engineering. I'll be your mentor Maruti Makwana for this particular course, and we are going to take you through the journey of Azure Data Engineering with various Azure related services like Azure Synapse, Azure Databricks, Azure Data Lakes, Azure Data Factory, and there are a couple of things which are associated with all the services. We are also going to focus on a couple of databases like SQL Server Database or Cosmos DB, which is a cloud-specific database of Microsoft Azure. This full course is going to be totally focusing on Azure Data Engineering, and it is also going to focus on the certification exam course, which is DP203. So if you're planning for the certification, or if you're eager to learn Azure Data Engineering associated with this kind of services, then you are at the right place. This video course is going to take you through the step-by-step journey. Before we start anything about the course, let me introduce myself. My name is Maruti Makwana, and I'm a corporate trainer from last almost 16 plus years of experience. I'm a Microsoft certified trainer, and I'm in this industry with Azure expertization from last almost 10 years actually. I have trained various corporate employees and number of tech giants actually, and I have trained various employees of tech giants, and then I'm helping them in cloud architecture designing and other things. Now that's it for me. Let's focus on this particular course and what extra things which are required for this. As I told you, this data engineering course is focusing on Azure related data engineering and specialized on DP203. So this particular exam is actually planned for getting the Azure Data Engineer Associate badge. So you will get Microsoft Certified Azure Data Engineering Associate kind of badge if you clear this exam. Now those who are already planning for DP203 or they are already data engineers working on Azure Cloud, they can actually go through this course, and this is going to be the perfect choice for them. But yes, those who are not very familiar with Azure Cloud, or those who are very newbie into this one, I should strongly recommend that you should go through my other course, which is DP900. For your kind information, DP900 is Microsoft Azure Data Fundamentals, and I strongly recommend that you go through this small shortest 3 hours course actually, which is actually taking you to the journey of data concepts, what kind of relational and non-relational data is available in Azure, and then how you can deal with the modern data warehousing. Once you go through this course, you will have the basic idea about the data associated with Azure Cloud, and then you can directly jump on DP203, which is actually the official course for Azure Data Engineering. In this particular course, if you go to the official exam page, Microsoft is going to tell you that we are focusing on this kind of 4 skills. So they are going to measure this kind of skills, which are focusing on design and implementing the data storage, which is having the highest weightage, no doubt. Design and develop data processing, design and implement data security, and then finally monitoring and optimizing the data storage and data processing. Throughout this particular course, we are going to focus on this kind of skills only, and we are going to make sure that you are able to understand the concept as well as you're able to implement this thing step by step. This full course is going to be much more advanced than the official learning path which is given by Microsoft. I know that most people are preferring to go through the learning path of Microsoft, which is a very good thing, but this is something which is going to be your beginning, or I can say very basic kind of introduction of the data associated with Azure. In this course, we are going to focus on little bit intermediate to advanced kind of thing, and that's why this is not something which is preferable for total novice users, and that's what exactly which is mentioned here also. So you can see Microsoft is also mentioning that this is not for the novice user. If you have dealt with data, if you have dealt with Azure Cloud, then maybe this is going to be the right choice for you. Now, before you take a decision to enroll in this particular course, I want to tell you one thing, that there are 2 prerequisites which are required for this particular course. One, I already told you that you need to have the knowledge of the basic data fundamentals actually. So if you have not gone through that, I strongly recommend you go and register DP900 course right now on mentorstech.com. Or otherwise, the second prerequisite which you have to go through is actually this one. Obviously, to do all the practical steps and hands-on of this particular course, you need to have an Azure subscription. If you have a valid Azure subscription which is given by your organization, that is perfect. If you don't have, then there are 2 different ways to get the Azure subscription. The first one is actually this one, which is available on azure.microsoft.com. This is the official website of Azure, and here you can get the free Azure subscription, which will come with $200 of Azure credit with 30 days of usage limitation in that. And this gives you a couple of services which are actually paid. But for your kind of information, this is one of the subscription which is not giving you Azure Databricks cluster development kind of thing. So if you are focusing on Azure Databricks much more in depth, and if you want to do the practicals of this particular course with Azure Databricks, then this subscription is not going to work out. So if you're planning for Azure Databricks in depth with practical kind of thing, then in spite of this free Azure subscription, you should go with something which is known as Microsoft Azure Pass. This Azure Pass is also nothing but another variety of Azure subscription which is offered by Microsoft. But this is something which mostly you cannot get free of cost. You can get it from my kind of official trainers, or maybe when you attend any kind of Microsoft trainings which we deliver for the companies. If you are joining for any yearly membership of mentorstack.com, you will get this kind of Azure Pass sponsorship free of cost. So if you have already registered for mentorstack.com premium memberships, you can just connect me with that, and we will provide one Azure Pass to you, which will be valid for 30 days with 100 Azure US dollar of credit, in which all the Azure services are available, which include couple of DevOps services, Azure Databricks kind of services, and all the services of Azure Data Engineering, including Synapse and all. All the services will be coming into this particular pass. All you have to do is you just have to go to mentorstack.com and you have to register yourself and just provide a proof through email to our official email ID, which is mentorstack@gmail.com or info@mentorstack.com. So you can use this email ID, or you can WhatsApp your payment screenshot on this particular WhatsApp number, and we will provide an Azure Pass subscription to you. That's it. If you already have a subscription, if you have already registered in mentorstack.com, this is perfect. You can start your journey with DP203, and I will take you to this journey by hand holding, by doing all the practical steps, practically step by step during this course. Thank you. Okay, now in this module, we are going to focus on Azure Databricks. Personally, if I tell you Azure Databricks is one of my favorite topic as a data engineer, this is one of the topic where, I have to focus maximum. In most of the organizations right now, or wherever I have delivered training sessions to all my clients, I know this thing that Databricks is one of the very important concept. And Azure Databricks is one of the coolest service which is provided by Azure. Obviously, the name itself is saying that it's the combination of Azure Cloud and Databricks, which is a separate service altogether. So before we understand Azure Databricks, let's deep dive into what is a Databricks actually. If you ask me a question, what is a Databricks, the answer is saying that Databricks is an open and unified platform for data engineering, machine learning, and analytics. It combines data warehouse and data lakes into a lake house architecture. This is very, very important thing. Actually, Databricks is invented by a company called Databricks. So actually there's a software company, and the name of the company and the name of the technology is actually Databricks. They invented the Databricks technology or platform, whatever you call it, and then this platform is really, really achieving great in data engineering, machine learning, and analytics kind of things. When you are dealing with Databricks, this one line is very important, that this is implementing data warehouse and data lake both combined into something which they are calling lake house architecture. You can see this image at the right side, which is showing me that this lake house is actually providing all the facilities like data warehousing, engineering, data streaming, and data science and machine learning. As well as this is actually available on all the popular clouds, not only on Azure. If you go to AWS and Google Cloud, the same Databricks service is available in the other clouds also. If you want to deep dive into what is a lakehouse architecture, you can visit this link which I am showing you on the slide, or very soon in the next video, I'm going to show you what kind of data warehousing architectures are there. And at the end of this particular module, you will be very clear how architecture wise, how practically you can implement the lakehouse architecture. But remember, it's a combination of data lake and data warehouse. Both. Now, the first thing which we need to understand is what is Azure Databricks, because as we mentioned, it's a combination of Azure Cloud and Databricks. So there are certain things and services which are actually taken care and provided by Azure side, and there are certain things which you will get from the Databricks side. Databricks is always going to be based on Spark. We have Spark clusters which can be having a Spark installed inside that, and then whatever logical data engineering code and queries which you are going to write, all those things will be executed by the Spark clusters. We have a Delta Lake architecture, which is one of the important concept of Databricks. We have different languages supported like Python, R, SQL or Scala. And then you can create notebooks. Notebooks are something like your programming, and one notebook can have multiple pieces of logic inside that, which we call cells. This all concepts of notebook, clusters, Delta Lake or Spark is all integrated inside Databricks, and that's what Databricks is all about. But when you come to Azure Databricks, if you are focusing on scaling, if you're focusing on some other application or service integrations, if you're focusing on some high availability or security, all these features will be provided by Azure, because ultimately Azure Databricks means the Databricks service hosted on Azure Cloud. So when Azure Cloud is going to take care of the services, they are going to take care of the integration, distributed file system, security, and everything else. Understanding the integration part of Azure Databricks with the other services like Data Factory or Data Lake Gen 2 or maybe some Power BI or machine learning service is one of the crucial topic of this particular section. Before we deep dive into Azure Databricks, and before we segregate what kind of things will be taken care by Azure and Databricks, let's move on to some of the terminologies which you need to be familiar in order to move forward in the Azure Databricks. There is a term called workspace. A workspace is nothing but an environment for accessing all your Azure Databricks assets. A workspace organizes objects like notebook, libraries, dashboard, and experiments into folders and provide an access to data objects and computational resources. This workspace will be something like your environment where you're going to work in Databricks. If you want to put some logic, if you want to integrate with some existing services, or if you want to integrate some data sources, all this you can do inside the workspace. The moment you deploy Azure Databricks service, the first thing which you get is a workspace. Inside that workspace, you can create multiple notebooks. A notebook is a web-based interface, or you can say it's a document which contains runnable commands, visualizations, and maybe narrative text. This notebook you can think like a class. Like if you're a developer, you know what is a class is. One class can have multiple methods, and each method is going to have some piece of logic. Same way, one notebook is going to have multiple cells inside that, and each cell is going to have some piece of logic inside that. When you're writing this logic, you maybe need to include some packages, some third-party libraries, or some predefined libraries of Databricks into this. These libraries will be those packages or ready to include kind of code which you can import in your existing logic, and then you can use it. Every programming language is having this kind of libraries, so I'm sure you're familiar with what kind of predefined libraries we mostly import and use. Finally, we have a fourth term, which is DBFS, Databricks File System. Databricks is mostly useful for compute, but as we said, it's a combination of data lake and data warehouse. Data warehousing is actually all the compute part kind of thing, but data lake is all about storing the data. When you want to store the data, there is a file system which is nothing but an abstract layer of a blob storage, because Azure provides blob data and blob storage with that. This kind of file system is integrated here. It contains directories which can contain data files, libraries, and images, and maybe some other nested directories also. DBFS is automatically populated with some data sets that you can use to learn Azure Databricks. So there are some open data sets, there are some predefined data sets which can be available there. When this kind of things are integrated, all these things will be available in your workspace. So you can use all this under one hood, and that hood is known as workspace. Another important concept and terminology of Azure Databricks is a cluster. Normally, a generalized definition of cluster means multiple computers or group of multiple computers. Here also it is like that. A cluster is a set of computational resource and configuration on which your notebooks are going to run. So if you have a notebooks or jobs kind of logic, and if you want to execute that, the compute power, the memory, CPU will be provided by the cluster. And there are mainly two kind of clusters actually, all-purpose clusters and job clusters. In this all-purpose clusters are going to be those clusters which you can manage by yourself. You can create cluster, you can stop cluster, you can terminate the cluster as whenever you require. All-purpose clusters are the most common used clusters in the most scenarios. But then we have one more cluster, which is actually job cluster. These are the clusters which are not managed by you. These are managed by the jobs or maybe the services which are integrated with the Databricks. You cannot start, restart, or create job cluster manually. This will be mostly created by the job. We also have something which is known as pull. When you do not want to use all-purpose or job clusters, we have a pool of clusters which is available. This pool is going to have one or more clusters running inside that, which will not be terminated at any point of time. It's going to be used whenever you need it, and then not terminated. It's going to be going back to the pool when you don't need it. This is one of the case which is rarely required, but yes, this is also sometimes in some scenarios pool will be the right choice for your cluster configuration. And then finally we have a last term, which is job. Job is nothing but a non-interactive mechanism for running a notebook. It's also kind of a logical notebook only, but this is something which is not having any user intervention or any kind of interactiveness inside that. This is just some kind of a background job which is going to be executed based on the schedule or maybe immediately the moment it is created. All these terminologies I want you to remember and understand, and then after this only you will be able to use all these things inside our first practical. So when we are going to create a Databricks cluster, we will see that how we can create clusters, how we can create this all-purpose or job clusters, where is our workspace, where are the notebooks, where are the jobs. All these things will be visible in that when we do the practical things. Thank you. Okay, so now once we know the basics of Azure Databricks, actually, it's the time to understand a very important part of Databricks and other data engineering thing, which is Spark. Now, if the question is what is Spark? The answer is Apache Spark is a sophisticated distributed computational framework. So this is actually a framework for executing code in parallel across many different machines. Now obviously one server or one computer is not going to be capable to handle the data engineering workload which we are going to do. That's why we have some computational engine which is going to make sure that whatever work we are giving, it will be executed in parallel across multiple machines, and these machines can be in hundreds of number. Spark is using clusters of machines to process big data by breaking large tasks into smaller ones and distributing the work among several machines. Now this is something like this, that if you have one particular query to execute or some kind of a data engineering workload to process, in spite of depending on one, we are going to divide that one large task into small multiple tasks. And then we are going to divide and distribute that into several machines, which normally we call executors. You can see right now in this diagram, we have two kind of machines actually. In Spark cluster, you are always going to have something which is known as driver. This driver is going to be main machine which is going to take your input. Whatever query executions, whatever data engineering task, whatever you're going to put in your notebooks will be executed by driver first. Driver is going to analyze that thing. It's going to divide that particular big data task into small chunks, and then that task is going to be executed by executor. Driver is going to assign the work to the executors, and then multiple executors are going to work. If you ask me in one Spark cluster, how many drivers and how many executors will be there? Well, the answer is in Azure Databricks and all, one driver is going to be there in the one cluster. So every cluster is going to have one driver associated with that. Driver is not going to execute the actual job. That will be done by executors, and that's why executors are going to be multiple in numbers. The maximum number which you can specify for executor is actually 200. So you can have maximum 200 executors connected with one driver, and that's how it's going to work. If I try to understand the work done by driver, executor and this task, then driver is the machine in which application runs actually. It is responsible for three main things: maintaining the information about the Spark application, responding to the user's program if some output is actually required for that, and analyzing and distributing and scheduling work across the executor. These are the main three tasks done by the driver. The actual work is done by executor as we discussed. So each executor will hold a chunk of the data that is going to be processed. Because we are dividing one big task into smaller ones, we also need to divide the data into smaller parts. These chunks are known as partitions. These chunks of the data are known as partition. It is a collection of rows that sits on a physical machine in the cluster. So you have to visualize this, that every executor is going to deal with one or more partitions and then it's going to use that data in order to execute the query executions. The executors are responsible for carrying out the work assigned by the driver. So each executor is responsible for two main things: execute the code assigned by the driver and then report the state of the computational back to the driver. These are the two main things executors are going to do. Then we have task. Obviously, task is that particular work which we need to perform. So these are the tasks which are created by the driver, assign a partition of data to process into that one, and the partition is something like collections of rows as we discussed. Then the tasks are going to be assigned to slots for parallel execution. Once you started, each task will fetch the assigned partition from the original data source and then it is going to be executed by executors. This is something which is a combined work of driver, executor and task, which is going to be performing inside the Spark framework. Also, one last and important thing which I want to add on here: when you're dealing with the Spark, all the executions are going to happen in memory executions. It means whatever executions are happening, we are fetching data from the physical disk and machine, but actually these executions are going to happen in memory. That's one of the reasons Spark is going to be much faster. Now, once we see the Spark cluster, it's also important to see Azure Databricks architecture. When Azure Databricks is implementing Spark, this kind of architecture is something which is going to be followed. You can see right now, the right side we have an architecture. We will see the implementation of this architecture in the next video. But you can see right now, whenever you're going to deal with Azure Databricks, first obviously you need a Databricks cloud account. Once you have that cloud account using which you create a Databricks, you are going to have a control plane and you are going to have data plane associated with that. This is my control plane inside which I have my notebooks which are created by the customers, some Databricks web application, some cluster management, that how many driver and executors you are looking for, and then what kind of jobs and queries are executing. All these things will be in the control plane, which we can control if we sign in with the Azure Active Directory or if we sign in with our own Azure cloud-based Databricks account. Once you do this thing, you're also going to have a data plane which is running in the background actually. This data plane is actually the one which is going to do data processing with Apache Spark cluster. So whatever driver executor actual work which is going to be done, that is going to be working on data plane. All the partitioning, all the chunks of the data which are going to be distributed and executing parallelly is going to be happening with this. But data plane is also continuously in sync with control plane, and whatever push-pull of metadata, logging data, all the things are going to happen in for each and every job and task. That's going to be the communication between control plane and data plane in such a way. Suppose in this data plane, sometimes data is not stored on Azure cloud and you want to get this thing from some external data sources. That is also possible. You can get the data from the external data sources, you can process that inside Databricks, and then you will be able to manage it in your notebooks or applications which are associated with your control plane. This full architecture is something which you have to go through maybe 2 times. Right now we are just seeing this thing as an understanding concept. But once we see the Databricks, after that I suggest that you should come back to this architecture and see this thing once more. At that time it's going to be much more making sense about the understanding of how the things are working. That's it for this video. Now let's see how we can create an Azure Databricks workspace with some clusters in the next video. Thank you. Okay, so now it's the time to create our first Azure Databricks service. We already know that it's a combination of Azure and Databricks. So let's see that how Databricks is going to work in Azure Cloud. I'm going to click on this Create Resource button, and you can see that we are going to click on Analytics, and then we are going to click on Azure Databricks. This Azure Databricks service is going to allow me to do everything which is possible inside the Databricks workspace environment. So we are going to create a workspace first. I'm going to select my subscription. We are going to create a new resource group. Let's say it's going to be something like Learning RG. Namespace for this particular workspace will be, I'm specifying Maruti ADB, Azure Databricks, and putting some number at the end of this. The location for this, I'm going to select East US, and the pricing tier for this, I'm going to select standard. In your organization, when you're using Databricks, there are chances that you're going to use premium because this is the only one which is supporting role-based access control and security management. As of now, I don't need that, so I'm going with the standard, and then I'm going to click on review plus create. All the other configurations are fine. Validations will pass very soon, and then I'm going to click on create, which is going to start the deployment of my Azure Databricks workspace. The deployment is completed. Now let's click on go to resource. It's taking me to my Azure Databricks service. Actually, inside this Azure portal, we have nothing much to do actually. We'll click on this launch workspace, and that's going to be the important place where we are going to work with Databricks. As we already discussed, that Databricks is associated with a couple of terminologies like clusters and notebooks and the different kind of configuration which are associated with the storage like Databricks file system. We are going to see all these components and utilities inside this. It's asking me what's my current data project. Well, I don't want to select anything. Even this get started window is also not important for me right now, so I'm going to close this. And now if you see this here, this left side column is actually the main important column. This is showing me that I can go with workspaces, repos, recent, search, data, compute, and workflow. The first thing which I want you to focus here is I want you to focus on compute. The compute section is going to show you that here you can create all-purpose cluster. You can also associate with job clusters and pulls. All-purpose clusters are those clusters which are created and managed by us. If I click on create cluster, we will have a configurational page where I can do the configuration. I can define the size of the cluster, how many drivers and workers, with what kind of configuration we want. We can decide all those things in this. As all-purpose clusters are going to be managed by us, we can also terminate that at any point of time. Then we have job clusters. Job clusters will be created by the jobs, not by us, and that's the reason there is no create cluster kind of button in job cluster. And same way we have pulls. One pull is going to have multiple compute clusters inside that, and on the fly we can just call the cluster from that and we can utilize that thing. But as of now in this course we are not going to focus on the pulls because pulls are the most expensive part of this. This is compute section of Databricks, and obviously this compute is going to be used to create and execute your notebooks. If I go to this workspace section, by default I have a shared and user kind of folders. Normally when you are working in a project, it's always advisable that you're going to create one folder inside the workspace with your name. Let's say I'm creating one new folder with my name, which is Maruti, and I'm going to click on create folder. When you're working on your Databricks workspace, you create all your notebooks inside this particular folder only. If you want to share it with other members, you can move your notebook from Maruti folder, your own folder, to shared folder. And then same way, whoever users which are associated with this, user specific resources also you can create from the users section. I do not want to create any notebook right now, but if I want to create, everything is available in this one click. I can create notebooks, I can create libraries, I can create machine learning flow experiments, or even I can import and export notebooks from any particular place. Then we have something which is a data section. Data section is the third most important section. All your structured data, like your databases, your managed Spark tables, all those things will be visible here in this data section. And if you are going to create a cluster, then with that cluster this data and the Hive meta store is going to associate. Once you create a table, once you click on this button which is create table, you will be navigated to one section which is showing you that you can upload any DBFS target directory based files here, and those files will be added into this. You can also drag and drop or upload files here. And you can check all the DBFS, which is Databricks file system kind of files, and the full file store will be accessible here. Yes, we can control this thing from the CLI, or we can control this particular file system from notebook also. This section is going to store all your data in your file system formats actually. Most of the time inside the DBFS, you can have Parquet files which are going to have Delta extensions. Because we are following Lakehouse architecture, this is quite common thing. There are a couple of places where you have to come back to DBFS and you have to understand what kind of files and structures are getting generated here. We also have a section which is other data sources. If you want to connect with some other existing blob storage, data lake storage, Cassandra, JDBC, Kafka, Redis or Elasticsearch, these are actually connectors which can allow you to connect with that. You just need to collect that, and then you can create tables in notebooks, you can associate with those connectors, and you can configure that. After all, we have section which is a workflow, which is one of the newest section for Databricks actually. Here you can create jobs. These jobs are going to use job cluster, and then you can also schedule the jobs as per your requirement. We also have something which is Delta Live tables. We are going to see Delta tables, and then we are going to try to include Data Live tables in the coming videos of this particular course. But yeah, this is one of the very new thing which I believe first you have to go through the basics of Databricks, and then you can go with this. There is a very awesome guide which is given here on this link. If you want to explore that thing, this quick start guide is really going to help you with Delta tables. Last but not the least, we have a section which is settings. The settings section is going to give you admin console, user settings, Azure portal, and manage account kind of configurations. For me, in this particular course, the most important one is going to be user settings, because this user settings is going to allow me to generate some kind of a security tokens. Using the security tokens, I will be able to integrate my Azure Databricks workspace with my other Azure services. I can also do Git integrations. I can also configure some notebook settings, email preferences, language settings. All these are extra options which are available here. In this course, we will mostly use access tokens and Git integrations kind of things. That's it. If you are able to create the workspace, now it's the time for you to create your first notebook and your first cluster. Let's see that thing in the next video. Thank you. Okay, so now once we have created one very simple first notebook, it's the time to explore some Spark transformations. As you can see here, my cluster which I have created in the previous video is still running, and I'm going to use the same cluster to add on some more Spark transformation kind of logic in my notebook. We are not going to create a new notebook this time. This time I'm going into my workspace, and inside this same workspace folder Maruti, I am going to import one existing notebook. Now for you, the logic of notebook is going to be very important to understand. I'm going to import my notebook. It's showing me drop the files to upload here. Now let's say I'm going to drag and drop my Spark transformation kind of Databricks notebook here. This kind of multiple notebooks I have shared in this course in the coming lectures actually. So exactly after this lecture, you have a couple of other Databricks notebooks to go through. But let's see how you can import this. It's very simple. You can just drag and drop, or you can upload that Databricks notebook here, and then you can click on import. The moment you do this thing, you will be able to import that notebook which I have created, like I have done this right now. Spark Transformation 1 is my notebook, and this one notebook is having couple of cells right now. You can see it's a lengthy notebook with lots of things inside that. What we need to understand is we need to understand logic. If I want to execute this notebook, I can attach this notebook with my cluster, and then either I can click on run all, which is on the top available here, and then each and every cell is going to be executed one by one. Let me click on run all. When I click on run all, you can see that running command 1, then 2, then 3 is showing me this kind of a notification message here, and every command is getting executed within few fraction of seconds. It has so many command executions which are there, and I think by the time I'm just completing my statement, this is done. This all the cells which are there are actually executed, and then everything is done just right now. Now when I'm showing you this thing, important thing is not whether this is running or not. Important thing is what kind of logic we have done and the concepts behind that. So let's focus on this logic right now. I'm sure concat is not a new word for anyone. We all know what is a concat means. Now in this case, I'm going to do Spark transformations with my Python logic. And initially I have imported some libraries. You can see from pyspark.sql, I'm trying to import some libraries, and then I'm taking types, I'm taking functions, I'm taking some window kind of thing. It is always advisable that in this particular notebook, every time when you need some libraries, you include that thing at that time. Like you can see in cell number 2, I have imported this, but then somewhere if I need few more libraries, like in cell number 4, in cell number 6, when I need some libraries, I'm going to import them whenever I need that. Do not import all the libraries in one shot, otherwise it's going to load everything inside the memory in the beginning itself, which is not required. After this, let's focus on this logic of this notebook. We have a data variable, which is actually having some data in an array format. And I have columns kind of variable, which is having some columns also in array format. What I'm trying to understand in this one particular cell is, we have something which is known as data frame. Data frame is one of the most important part of Databricks, because data frame is something like an in-memory table kind of thing. Because everything is happening in memory right now, when you create a data frame is going to create some kind of a tabular structure with your kind of schema and your data. So you can see I'm creating a data frame by calling this function, which is create data frame, and then I'm just adding that my data is going to be this and my schema is going to be columns. Once I do this thing, and if I call a function called display_df, this is going to show me that yes, this data frame is created with number of rows and columns inside that, which exactly looks like a table. The good thing is, when you have this in-memory table, it's not only visible as a table, you can get the graph from this. You can also get some plot options, and you can generate types of the graphs associated with this. This pictorial representation or materialized view of this particular data frame is already available. If you want, you can download this data in CSV format. You can configure the plot options as you want to analyze the data properly. Or if you want to check the data profile, that is also something which is going to be available when you attach this thing to the cluster run. I'm not doing data profile right now, but yeah, data profiling, visualization of the data, and visualizing the data as a table is all the added advantages of data frame. After this, if I move forward with the same kind of data frame, I'm going to do some kind of a transformations. Like you can see in this line of cell, I am trying to add one new column. With column is a function which can add a new column. I'm specifying that I want to concat a new column, which is going to be combination of first name and last name with space in between. And that's what I'm able to see in the output. It's going to create a new column with the name concat new with the first name, last name, and the space in between. And then the data frame is actually going to be updated. This is the same data frame df, which is going to be adding a new column now. Same way, in the next section, I'm using split. If I want to split one column value into two different columns, then I can use this. This function with column is going to create a new column with the name name1, and this with column is going to create another with the name name2. These two new columns are going to have some part of the data from concat new. And which part of the data we are taking? Well, we are specifying that we want to get first value, which is going to be the 0th item of this particular concat new before the space, and this is going to be the 1 item. So it's like they are dividing one value of this column into 0 and 1 by separating them with the help of space, and then this will be divided into separate columns. So this is like splitting one column value into two different columns. Then we have a when function. This when function is going to have a conditioning logic kind of thing. So we are creating one more column which is having a condition that salary greater than 3,000. Now the salary is actually one of the column of the data frame. If the salary is greater than 3,000, then it's going to display yes, otherwise it's going to display no. That's what this conditioning column is actually doing. And now I have another one more column added into my data frame. This kind of so many transformations we can do using Spark. And if you want to master Spark transformations, if you want to master Python logic and all, as many notebooks you see in this is going to be better. That's one of the reason Not only this one notebook, this kind of multiple notebooks I'm going to share in this course. So in the next lectures and after that, you can see in this module there are a couple of other notebooks which I have shared. All you have to do is just import those notebooks and then understand what is happening in that. Suppose when you're trying to understand that, and if you have some issues in any of the notebooks and cells, feel free to connect our mentors at mentorstech.com. Going to the cell number 10, which is going to have a simple function which is drop duplicate. But in order to use drop duplicate, I need to create my data with some kind of duplicated record. You can see we have one record here which is Jen Mary, which is a duplicated record. And when I proceed further, it's actually going to show me those two records which are same in the data frame. If I apply drop duplicate function on this data frame, then that record is not going to be there. So anytime if you want to drop the duplicates, you can simply call this function. Then we have something which is union. Now people who have dealt with RDBMS kind of database structure, union is not a new thing for them. But this union is actually slightly different. Like you can see here, I have created one simple data kind of data and then some column with that. And using this, I'm creating a data frame which is DF. The moment I create this new data frame with the same name DF, it's going to override the older data which I have in that. This new data frame DF is going to have a new data which I have given here, and that data frame is visible here. Now after this, I am creating simple data 2 also. Simple data 2 is having another data frame which is df2. And if you focus on simple data 1 and simple data 2, both are having same kind of schema, but both are having different data inside that. When I have this kind of things, if I want to apply union, I'm just doing df.union df2. When you apply this union, the combination of these two particular data frames are going to happen and you will be able to see combined data. Is it going to have a duplicate records or not? Well, that's the important question, and the answer of that question is yes, it is going to have an important thing. So you can see right now, I got some records duplicated, like this James Sales New York is coming from first one and this James Sales New York is coming from second one. The data is duplicated, so union here is just going to combine both of these data frames into one, and that's what this is visible like. Same way, we have pivot operations. Pivot operations are normally going to convert your rows into columns and columns into rows kind of thing. I have some data which has actually 3-column kind of schema. So you can see we have products, amount, and country kind of data here. We are creating a data frame called DF, and then normally this 3 columns are visible like this in this data frame. But now if I apply pivot on this, I'm specifying that I want to create a pivot data frame which is going to do group by on product and then pivot on country, and then I want to display sum of the total amount in that particular country. When we do this thing, you can see that that 3-column data frame is now changed into total 5 columns, where first column is product and another 4 columns are going to be my pivot, which is my country. Country wise, we are specifying that what kind of products are available and the sum of that product is going to be visible here. This kind of data visualization can help us to understand it in a better way. Couple of times pivot is going to simplify that and well organize the data, especially when you want to generate charts from that. After this, we have this expr expression function. This is actually allowing me to concatenate multiple values. So you can see right now, like what we have done earlier in the beginning, which is with the help of concat, we are trying to do similar kind of thing with expression, and the expression is showing me that this is going to be creating a new data frame right now. So this is just going to have 2 columns in column 1, column 2. But then when I'm applying this expression on this, I'm giving a syntax of some double pipe symbols are there, which will allow me to concatenate column 1 with column 2 with some comma separated value in between that. So this is something which is the use of expression. Couple of times at data validation and data format checking, we are using expressions actually. Then we have same way substring. The substring is allowing me to get a part of the value from the string. You can see we have a data which is having some kind of a 2 comma separated values in that. First one is like an ID and the second one is like a date. But if I want to get a proper date from this, I can use the function substring here, where it's going to take from the first character of that date to 4, which is year. Then it's going to take from 4 to 2. I think this should take it actually not 4 to 2. This should take 5 to 2. Let me change it. 5 to 2 is going to be 08 and 05 is showing 00 here, which is wrong. And then 7 to 2 means 28 and 25. That is visible here. Let me run this one cell because of this mistake. So I'm going to run this, and this 00 is changed now to 8th and 5th month. Perfect. This is what substring is doing. ToDate is also a very simple function, converting any normal string into a date format. So you can see that this is a very simple data frame which is having data and schema. But when I try to do df.print schema, which is going to show me the proper schema structure of that data frame, it's showing me that both the columns are actually string. If I want to convert particular column with the date, I am just adding one column here, which is going to convert this input timestamp into date, and that's which is a new column, which is date type. Once I print schema of this new data frame, is going to show me that this is actually having a type which is actually date. It's not anymore string. And then same way we have a date format kind of thing. We can format the date with your kind of choice of formats here. We have one current date which we are trying to display in the different date formats here, and that is which is visible in the data frame. And same way, if I print the schema of this thing, you can see first one is date, which is current date. All others are just different formats, but it's going to be treated like a string. Then if sometimes you need some logic where you want to get the difference between two different dates, you can use this date different kind of function. Date different kind of function is going to take two date, starting date and ending date kind of thing, and it's going to give you the exact difference between that. Like in this data frame, we are saying we are getting column date, and then we want to specify current date and the difference of that. When I'm doing date difference on this, it's going to show me how many number of days kind of difference is there. The same difference which you're getting between this two date, you can get this thing yearly also, monthly also, and round off also, which I have done inside this particular cell number 35. This one notebook is having 35 to 36 cells inside that. In each cell is having some piece of logic which is just doing Spark transformation. You have to understand basic Spark transformational logic, then only you will be able to master your Databricks. And that's why I strongly recommend that if you have gone through this video and if you understood this notebook, the other notebooks which I'm sharing with you exactly after this particular lecture, kindly import those notebooks and go through those notebooks one by one. Thank you so much. Okay, now in this particular video, we are going to access Azure Storage blob data into Databricks notebook. In order to do that, I need to create one new storage account. So I'm going to create a new storage account. Let's say I'm saying the name of the storage is my data storage. I'm going to have some data inside this which I want to access in my Databricks notebooks. Region will be East US, which is same like my Databricks workspace, and everything else is fine. We'll just click on review and create. When we are dealing with this particular storage account, you know this thing that storage account can allow me to store data in blob, files, queues, and tables. You know that storage account is going to allow me to store my data in blob, files, queues, and tables kind of format. In this particular case, we are going to use blob kind of data. So let's see that thing. Deployment will be done very quickly. Yes, my deployment is completed. Let me click on go to resource. Inside the storage account, I'm going to click on containers, and then I'm going to click on plus container. I want to create one new container because the data is going to be accessed with the help of Spark. I'm going to give a name of this container Spark, and then the access level of this container, as of now, I'm going to keep it private. We all know this thing that private containers data is going to be accessed only with security. So we have to provide some kind of a key and token somewhere if any particular Databricks workspace is trying to access data from this particular container. I'm going to keep it private only, and I'm going to click on create. Once I create this, inside this container, I'm going to upload some data. Because this is our first notebook which we are going to use, I'm going to keep my data very simple. I have selected one simple text file from my computer, which is this Kennedy inaugural.txt. This file is actually having a speech of President John F. Kennedy from the United States actually. So this is going to have some kind of a unstructured data inside this. Let me click on upload. This file is also going to be available with this video when you're going to try this thing. So you can find the resources of this video in which you'll get this particular file. If I click on this file and if I try to see the content of this, you can see that it's a totally unstructured data. It's just a human readable paragraphs which are there, and a couple of lines are there. I think 44 lines are there in this particular notepad file. This kind of unstructured data I want to use, and I want to write some analytical queries on this using Spark. My storage account and my text file is ready. Let me go to my Databricks, and the first thing which I'm going to do is I'm going to create a new cluster. So I'm going to click on create cluster. The name of the cluster is Maruti Makwana's cluster. That's perfectly fine. That's taking my username in that cluster name. It's going to be a single user. That's perfect. And who can access this thing is going to be me only. So that's fine. Performance wise, we have to select our runtime version. If you have some machine learning task, you can go with the spatial machine learning kind of cluster configuration. But I'm going with standard right now, which is default 10.4 LTS. What kind of scaling I want? Well, I do not want enabling auto scale. I do not want auto scale right now. I just want very simple one worker, one driver kind of a cluster right now, so that I can not waste my money in that. So it's going to be one simple cluster which is going to have 2 nodes inside that. A driver is going to have 14 GB memory and 4 cores, and a worker is also going to have 14 GB memory and 4 cores. As of now, this is perfect for me. If I scroll down, there is a section advanced options. This advanced option is having a Spark config, and this is a place where you have to configure that you're going to connect with which storage account. Whichever storage account you have mentioned, according to that you have to specify the key value pair here. Let me specify something like fs.azure.account.key. This is something which is a file system based account key which I have to specify. And then I have to provide my storage account name. Inside the storage account, if I go to the section which is access key, my storage account name is visible. This name I'm going to paste here. So this is going to be my storage account name .blob.core.windows.net. This is going to be my full key, which is actually fs.azure.account.key, then my storage account name .blob.core.windows.net. When you do this thing, make sure you're putting your storage account name here. After one space, you have to copy your key. That is going to be your either key 1 or key 2, anyone you can take, and then that key you have to paste here in this. Once you do this thing, this is going to be one key value pair which is configured for this. After this, you have to provide one more configuration which is going to be also including the storage account name. Let me put it there. I'm going to put spark.hadoop.azure.account.key. This is tough to remember in the first case, but yeah, if you practice it, you'll be able to recall this thing very easily. But this is something which I have to provide with my storage account name .core.windows.net. And then same way, I need to provide this key after one space. Don't forget to put one space here, otherwise this configuration will be corrupted. Once I'm done with this, I am just going to click on outside the space. And when I do this thing, you can see it's not showing me any error. It's a key, and then the key is having that particular token key which we have copied from the storage account. Now they are giving me a suggestion here as of now that you should never hard code a secret or store them into a plain text. Use something which is a secret API 2.0 to manage your secrets with Databricks CLI, and then secret utility is that. Well, this is one of the options where in spite of putting the key here, we can use it and then we can store the secrets there. Or we can also associate Azure Key Vault kind of integrations with this. That's an advisable thing for a real project environment. But right now I want you to see how the configuration works, and that's the reason I'm specifying this thing. I'm going to click on create cluster, and that's going to create my cluster, and it's going to take some time. So the cluster creation is started. It's going to take some time. After that, the cluster creation is going to show me green tick, and that is the moment I have to create my first notebook. Okay, now as you can see, my cluster is created and it is running successfully. all I need to do is I have to create my notebook now. So I'm going into workspace, going into that folder, and then I'm going to say I want to create my first notebook. What will be the name of this notebook? Let's say I'm saying this is something which is, I can say first notebook. I think it's a very simple name, first notebook. Language will be Python, and my cluster is going to be connected with this. So compute will be used by this cluster when you execute this notebook. And then I'm going to click on create. When you create this notebook, this is going to have multiple cells. You can see the CMD one is actually one cell where you can write your Python logic, or you can also write some markdown code. Markdown code is actually something like a comment or some kind of a header or some kind of other descriptive statements which you want to mention about your code. Like for example, because I'm going to analyze the speech of President Kennedy right now, I'm going to specify something like some kind of a header on the top of this particular notebook. So let me add something like this is going to be having %MD, and then I'm putting hash for the header information, and then the other detail information in the text. The moment I click outside for this particular one, this is going to show me Kennedy inaugurations, and then this notebook contains code to analyze President Kennedy's inauguration speech. This is a simple markdown kind of text. After that, I want to put my actual logic, so I can click on this plus icon. I can insert a new cell exactly below that, and always the execution is going to happen line by line. So after this, whatever cell I want to put here, we can do that thing. After this, in this particular cell, I'm going to put my configuration, which is like this. Python is a very simple language. You can see here I am specifying somewhere my storage account name. So I have to take my storage account name once again, and then I'm going to put it here in this particular one line of code. And what I'm trying to do is I'm trying to get a data from that Spark container. This is the name of my container. Then this is the name of my storage account, and then inside that storage account, inside this container, I'm looking for this particular file. Whatever I'm going to get from this file, I'm going to put it into this txt variable using sc. This sc is a Spark context. Spark context is going to help me to call multiple functions from Spark, and this is something which is an inbuilt function which I'm trying to call right now. If I do txt.count, this is going to show me how many number of lines are there in this particular notepad file. My execution is very simple right now. Let me just execute this one particular cell. When you execute the cell, this is actually going to associate with that particular storage account container. And if your connection string is proper, then only this is going to work. You can see right now, they are saying that the container Spark in the account Maruti storage, this blob not found. It means there is something wrong with my cluster configuration. This is a very common error which can happen here. And if this kind of error is happening, this simply means that they are not able to connect with your storage account which you have mentioned. And if that is the case, all you have to do is you have to go to your cluster and you have to reconfigure that thing. Let me go back to my cluster. I'm going to compute. I intentionally did one mistake there, and that's what I'm going to check right now. So I'm going into my cluster. I'm going to click on edit. The moment I click on edit, you can see that it's going to show me that advanced option kind of section there. And inside this advanced option kind of section, I have added an enter here. Normally this is going to be always like key and then only one space, and then you are going to get this thing directly. So this is like I have to put this key here with only one space. Then after this also I have to put this only one space, and then I have to put this with only one space, something like that. So this is my correct key value pair which I have here. After this, I'm going to just configure this. This is fine. I'm going to click outside, confirm and restart. And once we confirm this thing, after this, when we execute this cluster, once it is restarted, then it's going to work fine. This key value pair is one of the trickiest thing in this configuration right now. Suppose after this also, if it is not working, you can have a workaround. You can go to your storage account container, and then in spite of keeping this container private, you can change the access level of this container from private to container level. Once you set it to container level, then it is going to be accessible even without the keys. So you can see right now, if I just change it to container level, and then if I go back to my cluster, Let's wait for this to be running. And then if the cluster is running again with this new configuration updated in that, then I'm going to my, yeah, it is done. Then I'm going to my notebook, which is first notebook, and I'm going to execute the same cell once again. Let's see if this time it is working or it's going to give me the same error. Spark job is initiated, so it means it has actually detected my code syntax. The output is visible here, it's showing me 44. And remember guys, in that notepad file we were having 44 lines. By default, when there is no delimiter, it's going to take the new line as a delimiter, and it's showing me that txt.count is actually having 44 lines. Let me add few more cells and let's try to understand that thing one by one. So once we have this kind of thing, what we are going to do right now is we are going to write some analytical logic inside this, and using that logic we want to see what is working. So let me add one more cell. In this cell I just want to put something like txt, which is my variable, dot, and I want to specify first. If I have 44 lines, I want to see the first line of that. Let me run this cell. Within fraction of a second it is executed and it's showing me the first line. Vice President Johnson, Mr. Speaker, Mr. Chief Justice. This is the first line of that notepad file, which I'm able to retrieve it here. Then I'm going to click on one more cell. Let's say this time I'm going to create one new variable, and in that variable I want some logical entity. Let me do that. I have a new variable called field text, and in this field text I'm trying to do txt.filter. In short, now in that notepad file I'm going to apply a filter in which I'm specifying that this is going to give me a lines which are having a word freedom in that. And then I want to see how many lines are having word freedom, so I am just doing field text.count. If I run this cell same way in the unstructured data as fast as possible, you can see in 0.31 seconds only they found that there are 4 lines which are actually having a word freedom. If I want to see which lines are actually having freedom, same way I can do field text, which is actually my variable, and I can do dot collect. Collect is also a predefined function which is going to help me to get this thing. So I'm going field text dot collect. Let me run this cell, and all those 4 lines which are actually having a word freedom in that is going to be visible, and that's something which I'm getting here. So that's it. Even though we are dealing with unstructured data, the query execution is very fast because all these are in-memory executions. Databricks is going to execute in-memory executions, and that's what one of the greatest thing of Databricks. Let me click on the plus icon once again, and I want to add one last piece of logic in this notebook file. Let me add something like this. This time I have a logic in Python which is trying to get the words from that notepad. So it's like I'm trying to get the words because of the space delimiter from that. Once I get all the words, I want to count how many words are there. So that's why I'm using a 2 lambda combination. We'll count the word, and then if a same word is coming once again, we are going to increase the counter of that thing. And at the end of this, I want to display the sorting of that particular numbers. The word which is having the highest count is going to be coming on the top, and then the other numbers will be coming in that same list likewise in that. I'm done with this. This execution is also very fast. You can see it's just done in less than 2 seconds, and they have analyzed all the words with how many times they are appearing in that. Like the word "the" is used 83 times, the word "of" is used 66 times, and same way it is giving me the long list there, which is showing me list of all the words. The processing is very fast. That's one of the greatest advantage of Databricks notebooks, and the cluster which is running in the background is doing and providing all this compute with this. I hope you understood this first notebook. This notebook is going to be available in that same video course, so you can just find that thing in the resource of that one exactly after that particular course title. You can also import and export this notebook. So all I need to do is I can go to my workspace, I can go to this notebook, and if it is working fine, I can export this thing in DBC archive format, I can export this thing in HTML format. All these options are available and it will be downloaded there. Thank you. Okay, now once you have gone through all those notebooks and you already know that we have this interactive cluster or all-purpose cluster which is already there in Databricks, it's a time to see job cluster. But as we discussed, job cluster is not something which we can create from here. It's always going to be created by the jobs. So either I have to go and create some jobs in Databricks, or maybe I can integrate with some other services of Azure which can use Databricks for the compute engine. Now let me try to do one thing. Let me create a very simple notebook here first. I'm going to create my new notebook. So I'm going to say create notebook. And let's say the name of this notebook is, we are just saying that integration ADF. We are going to integrate with Azure Data Factory using this. So I'm giving integration ADF is what we are trying to do in this notebook. It's going to be Python. As of now, I'm going to select this cluster, but you know this thing that my cluster is actually terminated right now. So I went to this compute and I have terminated that cluster. It's not running anymore. I want to associate a job cluster with this particular notebook. So I'm going to associate my integration notebook with that. Let me put some code here. I have a very simple code which I want to add on here, which is going to associate with some kind of a notebook parameters. I copy pasted this. You can see here, initially I have some Databricks utilities, which is known as dbutils. And then using that, I'm trying to get some values from this input parameter. Then whatever value which I'm getting in the input parameter using this variable y, I'm going to get that. And then I'm going to put it into this particular print. Now, this is a very simple notebook, but important thing is how we integrate that with ADF. So let's go to ADF and configure that now. I'm going into my other Microsoft Azure portal tab, and in this Azure portal, I have created my Azure Data Factory. Let me just open this Azure Data Factory Studio. We already know how to create pipelines, data factory, link services, data set, and all these things. So this is my new data factory, and what I'm going to do right now is I first want to create a link service. As of now, when we discuss about link service, data set and all in the previous videos, we know that link service is going to provide a connection to the data store. But let me take you through this manage section first. I do not have any pipelines in this as of now. I can create it. But before that, let's go to manage section. And what I want to do right now is I want to create a new link service. You can see right now they are mentioning here that when you are creating a link service defines the connection information to a data store, which we have seen so far that we always connect to some kind of a data store where we store data. But it also has some option here which is known as compute. This compute option is going to be very important in this particular one, because right now when you're going with Azure Databricks, that is not a data store, that's a compute actually, because Databricks is going to provide a computational power. It's not going to store data inside that. Let me click on the plus new of the link service, and you can see we have two options, data store or compute. I do not want to go to any data store option now. I'm selecting compute. In compute we have 5-6 options here. We can use Databricks, which we are going to use right now, or other than that we can also use Azure Function, Azure Batch Services, Machine Learning, or any of these options which are available there. Let me click on Azure Databricks, and then I'm going to click on Continue. When I select this thing, this is going to be my Azure Databricks based link service. So I'm giving a name Azure Databricks LS, and then it's going to use auto resolve integration runtime. It's going to ask me which subscription and which Databricks workspace you want to associate with this. I'm going to select mine. And then this is the place where I have to select that whether I want to create a new job cluster or I want to use an existing interactive cluster. If I want to use existing interactive cluster, that is also going to be done. But because we are trying to understand job cluster right now, we are selecting a new job cluster. Exactly below that, they're asking me that any service cannot have a rights to create a Databricks cluster. So if you want to do that thing, you have to provide a secure access token in this. Let me go to my Databricks. I'm going to click on settings, and then I'm going to click on user settings. This user settings is going to allow me to create a new access token for my Databricks, using which any other services can create a cluster and can access the particular jobs inside this Databricks workspace. I'm going to generate a new token. It's asking me this is for what? Well, this is actually for ADF. So I'm giving a name for ADF. I'm going to click on generate I'm going to copy this token and I'm going to click on done. Once this token is generated, I will not be able to see it once again. It's just one-time process where I can generate and see that. And that same token which I have copied, I'm going to paste it here. Using this token, someone or any other application can connect with this particular Databricks. The moment I put the token, is asking me some more configuration like what kind of cluster version I want, what kind of cluster node type I want. I am going with some basic version configuration and some very basic small size node type. So that is going to be created. Python version, I'm selecting 3. Worker is going to be 1. So it's going to be 1 worker and 1 driver kind of a nodes which will be configured here. Now let me click on test connection. If everything is fine, if token is validated, it's going to show me connection successfully done. And then I can click on create. This is going to create my first new link service, and this link service is actually allowing me to connect my data factory with my Databricks. So that's why it is available here. Now this is the time we have to use this link service in our pipeline, and then we can invoke that notebook which is actually there in Databricks using this particular pipeline of data factory. Let me go to my author section. I'm going to create a new pipeline. I'm going to select a pipeline name like this is going to be pipeline with ADB with Azure Databricks notebook. I'm saying pipeline with ADB notebook, so that is fine. And once this pipeline with ADB notebook is created, let me collapse this section. I am going to take an activity which is going to be Databricks. You can see that you have 3 activities here: notebooks, jar, and Python. If I can use jar, Python in Databricks, I can integrate those things also here. I'm going to select notebook, which is actually my activity, and this is going to be the only activity which I'm going to add in this particular pipeline. I can have multiple notebooks also added one after another in this flow, but let's add one notebook. Below that is asking me that if this is a notebook, it's going to associate with which Azure Databricks link service. I'm going to select my link service which I have created in the previous step, and if that link service is created, then it's going to ask me that this is going to associate with which notebook path. Let me click on browse. I'm going to browse my notebook which is inside the Maruti folder, and then it is inside this one. This is integration ADF is my notebook which I want to invoke and integrate here, and then I'm going to click on OK. Now this is something which is a simple connecting integration of this notebook with that particular Databricks using this link service. But now we should not forget one thing, that our notebook is actually having one parameter inside that, which is input. If I want to run this thing properly, then this input parameter I have to provide from my data factory. In order to do that, I'm first clicking on this white surface of this designer. There is a pipeline parameter which I can create. Pipeline parameters are going to be required when you trigger the pipeline. So let's say I am giving a name of my pipeline parameter. This is my parameter 1 of my pipeline, where I'm going to pass on some value, and that value is going to be required and used inside this notebook activity. That's what I'm going to do. So this is my pipeline parameter param, which is not having any default value right now, but it's just going to have some kind of type. And then if I go to this notebook activity, in every notebook activity, we can define multiple base parameters. This base parameters will be passed into this particular notebook when it's going to be executed. I'm going to click on plus new, and I'm saying my notebook activity is having one parameter which is input. This name of this particular base parameter should match with your logic which you are using inside this notebook. So this is input and this is also input. From where this is going to get the value of that input, actually I'm configuring that the base parameter is going to get the value of my pipeline parameter. So I clicked on this dynamic content and I'm going to select param1, and then I'm going to click on OK. This is a right to left assignment. The value of my pipeline parameter will be assigned to my base parameter of my notebook activity. If we are done with this, we are good to go. I'm just going to click on validate. Validate is not having any errors. Then I'm going to click on publish all, which is going to save this pipeline. And if publishing and validation both are done, then we are ready to trigger this pipeline, and we need to see that whether the job cluster is getting created with this or not. Publishing is going on, it is completed, very well. If publishing is completed, all I'm going to do is I'm going to click on add trigger, and trigger now. When I do this, the pipeline is showing me that param1 is the parameter for which I have to give value. I am giving a value in this. Let's say I'm passing mentors tag. I'm giving a name of my website, mentorstag.com or something like that. So I'm just giving that name. Whatever parameter value we are passing here, it should be passed into that particular Databricks notebook. If I click on the bell icon, it's going to show me that the pipeline execution is started. It is actually showing me that pipeline is executing right now. Now this time, this pipeline is going to take a longer time. Even though the notebook code is very small and simple, it's going to create a cluster first, and that cluster creation takes approximately 4 to 5 minutes. You can see right now, if I click on view pipeline run, it's taking me to this monitoring section where it's still in progress from last 26 seconds. Let me go to my Databricks and let me observe whether this is actually creating a job cluster or not. If I go to compute section, this is actually showing me that in the job cluster, it's trying to create a new job cluster. As I said, this cluster creation will take some time. This is going to find out the new instances, is going to create one new cluster with those 2 nodes, one worker and one driver, and that job cluster is dynamically created from that Azure Data Factory. I think now it is much more clearer that where and how we can use job cluster. Job cluster creation will take 3 to 4 minutes of time. Let me explain one thing right now, that when exactly you're going to use all-purpose cluster and when you're going to use job cluster. Now you can see right now, one clear scenario which you are able to see is this, that even though I have a very small notebook, the job cluster creation is going to take 3-4 minutes of time. So to run this kind of simple pipeline also, I have to wait for a longer minutes. Now this is something which is nonsense, because if I have to wait for 4-5 minutes to just execute few fraction of second kind of code, then it's something which is not a valid thing. Normally job clusters are going to be created for some long running task. If you have a task which can take few minutes or even hours, then at that time you will not maybe count this 3-4 minutes of cluster creation time. And then the moment job is done, it's going to be terminated automatically. Right now also, if we wait for some time, this cluster is going to be run, it's going to be started first. Right now also, if we wait for some time, then this cluster is going to be started. It's going to show me running for a few seconds, and after that it's going to be terminated once job is successfully executed. Let's wait for this. Yes, you can see that the job cluster is successfully created and it is running right now. The moment it is running right now, we have to wait for a few seconds. Within few seconds, obviously the huge compute which is associated with this cluster, which is 8 cores and 28 GB RAM, is going to complete that code. The moment this is executed, it's going to show me cluster is terminated. You can see it's showing me job finished, and then the cluster is going to be terminated. This is like one job cluster executed their job, and then once it is done, now it is in terminating state. Very soon it's going to be terminated. Now the question is, yeah, this is terminated right now. Job finished, cluster terminated. Now I can go back to my pipeline. I can see that the pipeline execution is showing me succeeded. The total time taken by this is 4 minutes and 11 seconds. If I want to see the details of this execution, I can click on this glasses kind of icon on this, and if I click on this, it's showing me one URL which is actually something like run page URL. If I click on the run page URL, it's going to ask me to navigate to this Databricks workspace, and here we have that code. You can see that the code which I have executed in that notebook is visible. Exactly below that code, the output which we have printed is also visible, and the name of my website mentors tag is also visible there. This is something like showing me that this code execution took only 0.3 seconds. But if I actually focus, it took almost 4 minutes of time. So this is a time which is taken by the job cluster creation. I hope you understood the job cluster and interactive cluster both. And obviously, you can try the same kind of integrations once again by creating a new link service. But maybe this time when you create a new link service with Databricks, you can just choose, in spite of job cluster, you can create existing interactive cluster, and that's not going to take this time because the interactive cluster is already running. It's just immediately going to execute the job and it's going to give you the output. But cost wise, because this is continuously running, interactive cluster is going to cost you more and job cluster is going to cost you less. I hope you're getting this. Thank you.